Butterfly effect. The idea is that a small change in a system could result in a massive change or chaos over time. How a tiny change leads to larger destruction. Let us explore them in detail in this video. For example, let us imagine a teaspoonful of air molecules moved by a butterfly flapping its wings in Brazil. This can be amplified over time to create unpredictable outcomes, such as a tornado in Texas. Science has been devoted to developing simple models that predict the behavior of systems. Certain phenomena in nature, such as planetary motion, lend themselves readily to this schema. With a description of the initial conditions, the mass of a planet, its position, velocity, and so on, future configurations can be calculated. However, the behavior of many processes, such as waves crashing on a beach, smoke rising from a candle, weather patterns, they are chaotic and unpredictable. Chaos theory seeks to explain such unpredictable phenomena. The first strides toward chaos theory were taken in the 1880s, when French mathematician Henri Poincaré worked on the three-body problem. Poincaré showed that for a planet with a satellite orbiting a star, an Earth-Moon-Sun system, there is no solution for a stable orbit. Not only was the gravitational interaction between bodies far too complex to calculate, he also found that tiny differences in initial conditions resulted in large and unpredictable changes. However, his work was largely forgotten. Few further developments occurred in the field until the 1960s, when scientists began to use new, powerful computers to predict the weather. Edward Lorenz, an American meteorologist at the MIT, tested simulations involving just 3 simple equations. He ran the simulation several times, each time inputting the same initial state and expecting to see the same results. To his surprise, he never got the same results. Checking his figures again and again, he found that the program had rounded up the numbers from 6 decimal places to 3. This tiny alteration to the initial state had a major impact on the end result. This sensitive dependence on initial conditions was named the butterfly effect. Edward Lorenz defined the limits of predictability, explaining that the impossibility of knowing what will happen is actually written into the rules that govern a chaotic system. Not only weather, but many real-world systems are chaotic. Traffic systems, stock market fluctuations, the flow of fluids and gases, the growth of galaxies. They have all been modeled using chaos theory. Another example, turbulence forms at the tip of a vortex left in the wake of an aircraft's wing. A message from this scientific method to our life are, we can't control everything but regulated many of them. An initial tiny mistake can lead to a complex ending. Pay attention to even tiny things for less chaotic outcome. Thanks for watching. Please like, subscribe and share.